For a long time, Western philosophers have argued over the question, is change possible? Heraclitus answered that everything changes, while Parmenides answered that nothing changes. Parmenides had a student named Zeno. He followed Parmenides' tradition of denying change and tried to prove it. But wait, is it possible to prove that nothing changes? Yes, he did. It's a little weird, but Zeno did it anyway. Today, we'll take a look at how he tried to prove that nothing changes. Zeno came up with thought experiments that ultimately end in a paradox. They are called Zeno's paradox. The first paradox is the paradox of Achilles and the tortoise. The Greek hero Achilles is in a foot race with a tortoise. Achilles can run 10 times faster than the tortoise. So he lets the tortoise have a head start of 100 meters. Who will win the race? It seems obvious that Achilles will. But no, Achilles can never beat the tortoise. Let's see why. When Achilles reaches the starting point of the tortoise, or the 100-meter point, the tortoise will have moved 10 meters. And when he travels 10 more meters, the tortoise will have moved 1 meter. And when he moves 1 meter, the tortoise will have moved 0.1 meter. No matter how many more times Achilles moves, the tortoise is farther ahead. Achilles can never catch up to the tortoise. The second paradox is the paradox of the dichotomy. Suppose that Usain Bolt is running from point A to point B. In order to reach point B, Bolt has to reach point C, which is a halfway point. And to reach point C, he has to reach point D, which is the halfway point from A to C. And to reach point D, he has to reach point E, and F, and G, and H, and I, and so on. This means that in order to reach the final destination, point B, Bolt has to pass an infinite number of points. Therefore, Bolt can get infinitely closer to point B, but he can never reach it. The third paradox is the paradox of the arrow. Zeno says a flying arrow cannot fly. What does this mean? Let's capture an arrow and fly it at a certain instant. At this instant, the arrow is not in motion. It's motionless. How about at the next instant? Still unmoving. At every instant, the arrow is motionless. But time is composed of instants. In other words, the instants form time. Then the arrow cannot possibly be in motion, because time is composed of instants at which the arrow is motionless. Zeno's point is this: when we assume that something is in motion, we fall in a paradox. Therefore, motion is impossible. But why do we see them moving? It's because we view the world only with the eyes of our senses. When you view the world with the eyes of reason, you will see that it is actually motionless. In order to see the real world, you have to see it with the eyes of reason, not the eyes of our senses. That is Zeno's conclusion. What do you think? Do you agree with Zeno's paradox? I don't think there have been many people who do. There have been many refutations to his paradox. Let's take a look at the 19th century French philosopher Henri Bergson's solution. According to Bergson, time is not something that can be added, divided, or paused. Time just flows. Therefore, we cannot pause time at the instant Achilles reaches the starting point of the tortoise, or when Usain Bolt passes a half point, or when the arrow is in flight. The paradox occurs when you try to divide time. Think of a metaphor. Listen to a part of Beethoven's Fate Symphony. It's so familiar. But what happens if you divide this music? The original melody is all gone. It's the same way with time. When you divide time, it is no longer time. But why do we think that we can divide time? It's because we confuse time with space. Space can be added, subtracted, or divided. we get confused and think that we can add, subtract, or divide time. But time just flows. Bergson's solution is actually a challenge of physics. Physics quantifies not only size, mass, speed, and force, but also time and space. Then it adds, subtracts, divides, and multiplies them. So if we accept Bergson's claim that we cannot quantify time, physics is also wrong. For that reason, Bergson actually challenged Einstein's theory of relativity. He thought that time cannot be slowed down. Zeno's paradox must have pissed people off in the ancient Greece as well. Zeno got on the king's bad side and was sentenced to death. According to some stories, at his execution, he lied that he had some great secret to tell the king, and when the king came near him, he bit the king's ear off. It's said that he was still holding on to the king's ear after his head was cut off. There's also another story. When he was sentenced to death, Zeno gave a book to the king and told him that there is a secret hidden in it. The king licked his fingers to turn the pages, but there was nothing in the book. Seeing this, Zeno cursed the king, saying, "I put poison on the pages, so you will soon die as I will." Not all of this may be true, but it's clear that Zeno's paradox baffled people. But that doesn't mean we can just ignore it as a play on words. No matter how absurd it may seem, his arguments were formed as logical arguments. At first, they seemed to make sense. And as we try to find where his logical argument went wrong, we can draw new ideas. For example, while examining Zeno's paradox, we can come up with new ideas about what time is. In that sense, he succeeded in leading philosophy into a very rich discussion. Let's wrap up. First, Zeno showed that we fall into a paradox when we assume that something is in motion. This was to prove the idea of Parmenides, his teacher. Parmenides had claimed that change in motion is impossible. Second, as a solution to Zeno's paradox, Bergson said that time is something that flows and cannot be paused. Bergson's argument leads to a challenge against physics. Third, Zeno's paradox may seem like a play on words, but it led to many philosophical discussions. It especially led to new ideas about the nature of time.